Hi everyone. So this is a session about Docker. We will have a look about introduction to Docker, and I'm trying to cover the Docker basics and a hands-on session about how to install Docker on a Linux machine and how to run a container, then how to commit the changes, how to create Docker files, and how to run them, and about how to interconnect containers and run in volumes and port mappings. Okay, so when it comes to current industry, the main challenge we are facing is we have different kind of technologies like Nginx, Python, Ruby, then Redis, Hadoop, Thrift, OpenJDK, Flask. So we have different kind of technologies that are used for developing the websites or the applications, and they are running on different kind of environment. For example, it may be run on a development VM, it may be run on a QA server, and it may be run on a customer data center or public cloud or private cloud. So when it comes to these kind of different technologies, so they will have different kind of dependencies, and sometimes a development VM may be running Python 3.0, but when it comes to production environment, you will have to update the Python versions and the dependencies, and it's really hard to manage this complex environment because we have different kind of multiple technologies that we need to run on different kind of environments. So we will have a look about the cargo industry in 1960s. So it also had different kind of goods like cars, barrels, and wood cartons and bags. So when it comes to the mode of transportation and storing, it was really hard because the different kind of cargo has different kind of shapes, sizes, and it was really hard to store them in a single location, and it was really hard to move them because they had the lorry or train or ship was designed to or specific to carry. They were not designed to carry different kind of goods. So there was a solution came for the cargo industry, that was the intermodal shipping container, where they defined a container where they will put the goods inside the container and it will be sealed, and it doesn't matter about when it comes to transportation and storing, it doesn't matter about what are the goods inside that, as long as it is a container, since they can build the storehouse and things to the sizes of the container, and it was really easy for transportation goods around the world. And still the shipping industry used the same concept for transport goods around the world. Okay, so actually Docker is also a shippable container, so we can say it as a shipping container for system for codes. So when it comes to a Docker container, we package the application dependency and other things inside a container, and when it comes to running it, so it doesn't matter whether it's a development VM, QA server, or customer data center, or public or private cloud, it will run anywhere with the same output. Okay, for example, a developer did some application development using a Docker container, and he has the container, so he can easily move it to QA server and run it in there. So it should run there since all the things are packaged inside the container. The environment or the hardware that it is running is not a matter to run in a container. Okay, so why developers care about Docker containers? So we can say it has built once, run anywhere. So it's a clean, safe, hygienic, and portable runtime environment for your application. So it is really portable, and you can package all the dependencies and the application to a container. And they don't have to worry about the mixing dependencies and packages and other things when it comes to deployments. Since all the things are inside the container, when it comes to deployments, when he move the container to environment to another environment, it should work there without any errors. So this is really easy because sometimes when it comes to deployments, a QA environment, sometimes for example, when it comes to QA environment, it will work, but when it comes to production, it is not working. So you need to check what are the dependencies, is the dependencies versions are same on both QA and production and things like that. And it is really hard for the deployment. But when it comes to Docker, you don't have to worry about those things since all the things are inside the container and it is a self-managed thing. And there's another advantage. For example, a developer need to write two application. One is running on Python 2 and another one is running on Python 3. So he have to install both of them on in his machine and do the deployment. But it is really hard because Python, when we have two different version of application like Python, it is really hard to manage it. So what he can do is he can have isolated environment using Docker and install Python 2 inside the one container and Python 3 inside another container, and it will not affect the host machine since it is inside the container and container is isolated thing. And when it comes to automated testing, integration, and packaging, and anything you can script, it is really easy to use Docker containers for like automated testing. So you can spin up the whole environment inside a single machine using containers and use automated testing for test those things. And it will reduce or eliminate the concern about compatibility on different platforms. For example, a customer sometimes want to run the application on his dedicated server, and suddenly he changed the decision to move it to a public cloud. So he may have concern whether it will run there with the same dependencies. So the developers don't have to take care about those dependencies because a container has all those things inside that, and it will not affect the, it will not, you don't have to think about the environment that they are running. Okay. When it comes to DevOps engineer, so we can say it has configure once, run anywhere. So it will make the entire life cycle more efficient, consistent, and repeatable because we have a container, we can start, stop, and a container will start within 2 or 3 seconds, and you can easily move them. Because of them, the continuous integration, continuous deployment pipelines will be easy to manage, and the deployments will take less time. And it will eliminate the inconsistency between development, test, production, and custom environment because we are using the same container with the same dependencies. And it will help to improve the speed and reliability of continuous deployment, continuous integrations. And since they are lightweight, and it will make some performance improvement and cost improvements, a cost reduction when it comes to use Docker containers. So for example, we may have an application that utilize high network bandwidth, and because of that, we use when it comes to, so if you are using AWS, so you will take a server that has good network bandwidth, but it doesn't want a CPU, much CPU or much memory. So it's a waste of money because since you wanted a network bandwidth, you have to go to a large server, and you doesn't utilize the resources inside that. So what you can do is you can get a large server and then run many applications inside that, So it will utilize the network bandwidth of that, and you can uh, save money and save time, and the performance also will increase because you can run many containers inside the single server. Okay, this diagram shows a separation of concern. So, for example, the Dan, the developer, he just worry about what's inside the container, his code, his libraries, the package manager, and his application and his data. And he doesn't have to worry about what's outside the container since it is managed by the operation guys. And when it comes to Oscar, the ops guy, he does have to only worry about what's outside the container. He doesn't. He does have to worry about how to manage the login, monitoring, how to manage these containers, things like that. And he doesn't have to worry about what's inside the container. He doesn't have to know about that. He just have to run it, and that's how the Docker is used to separate the concerns between the development and the operations. Okay, let's see what is the difference between a container and a VM. So when it comes to virtual machine, we have a server. If you are using type 2 hypervisor, we install a host OS, and top of it, we use a hypervisor. Then you have to install the whole OS on top of that. Then you have to deploy the application, and the dependencies also you have to install. But when it comes to Docker, you will have a server. You install a host OS on top of the server, and you install Docker daemon, and it will use Linux LXC namespaces, and so you don't have to run guest OS. So it's just running a container. It has some part of the whole. You have to have some part of the OS, but it is shareable between all the containers. And because of that, they are really lightweight and really fast and easy to migrate and easy to manage because there is a less overhead when it comes to here you have a guest OS and bin libs, everything, and the hypervisor layer. There is a huge overhead, but when it comes to Docker container, it is really less overhead. And the size of the container is also really small when you compare with a VM, because a VM contains the whole guest OS installed, but the container it only have the things that is necessary to run the container. Okay, so let's see why are the Docker containers lightweight. So when it comes to VMs, as I previously mentioned, each app, each copy of an application is another VM, where it may take like sometimes it may take 10 to 50 GB for a VM, depending on the OS and other dependencies you have. But when it comes to a container, as you can see in this image, so original app, it doesn't take OS space and resources and things like that. So it just has the dependencies and the application. And even you take a copy of it, it's just copying the application, and it doesn't copy the host OS part. And for example, you get modified the application, it will work as a layers, where it will add a new layer on top of this container, where you have to only write this new layer to the container, and it is mainly it's working like how the GitHub works. So we will have a look about what are the basics of the Docker system. So when it comes to Docker, you will have to have a Docker file first, or Docker file, or Docker image. If you want to build a new Docker image, so you have to write a Docker file. Then it may be stored inside the local code repository you have. Then using Docker engine. Docker engine is the engine that Docker used to manage the container. So using Docker engine, we build this Docker file, and it will the output is a container, or you can say it as an image of a container. Then using push command. So there is a command in Docker to push a image to a Docker repository. So Docker repository, it is same. You can say uh, it as same as GitHub or source control repositories, where it will store your image when you push it. Then on another machine, you can pull that image, then run it, and you can search for the images in the registry. And the most important thing is, even if you do some changes to this Docker file and build it again and try to push it, it will only push the changes that you have done. It will not push the whole container. Even when you pull a container, it will only pull the changes that it has. It will not pull the whole container. Because of that, the bandwidth and network bandwidth, it will save when it comes to your machine. The network bandwidth it takes will save when you use Docker. Okay, so this diagram shows how this pushing a Docker container happens. So you have a base container or image, then you modify something on top of that container, and then there may be some changes to the bin libs also. So the application layer and the dependency layer, they will have changes. So when you push it, it will only push these changes that you have done to the Docker registry. And when you update the container or pull the container to another host machine, so it will only update if it has the previous one. It will only update the things that you have updated. And now the second host is running container a double dash. So when it comes to Docker registry, you can use, there is a Docker Hub. Docker Hub is the Docker's own registry, so you can use it. So for public repos, it is free. For the private repos, you are given, I think, 2 or 3 repos. Other than that, you have to pay if you want to maintain a private repo. And you can also host your own repo, and the cloud environments like AWS, Google Cloud have their own repositories, so you can use a repository as a service also. So we'll have a look about what is a Docker engine. When it comes to Docker engine is the client-server application, which has 3 main components: a server, where a daemon process is running, that is called Docker daemon, and there is a REST API built top of that, where you can use it to interact with the Docker environment. And then there's a Docker CLI. Docker CLI, you can use either Docker API, REST API, or Docker CLI to manage a container. So if you are running like more than 2 nodes, cluster environments, and managing a Docker cluster, so this REST API is used. But if you are using it in a single environment, single instance, so you can use the Docker CLI. When it comes to Docker engine, so you can use like it is running as a daemon, and there is a REST API also available. And you can also use custom clients. By default, the server listens on a Unix socket run docker.sock, and you can additionally add another endpoints. And when you come to the client, so it will try to connect to the Unix socket, and you can also give the alternative binding using -h parameters. And Docker daemon is running as root, and it assigns the default unit socket to the Docker user group if it is available. So when it comes to Docker, so currently it has two versions, Community Edition and Enterprise Edition. Community Edition is free, and it has monthly edge releases with latest features for developers and quarterly releases with maintenance for operation guys. When it comes to Enterprise Edition, it supports container as a service, and it has subscriptions, and enterprise support is there, and there it has quarterly releases, and there is supported for 1 year each with backported patches and hotfixes when it comes to Enterprise Edition. And it will also contain certified technologies, infrastructure, and plugins and containers that they are certified with Enterprise Edition. So this chart show what are the Enterprise Editions we have at the moment. We have Basic, Standard, and Advanced. And you can see there are like different kind of features that are available on different kind of versions. Okay, so let's see how we can install Docker. When it comes to Linux, it is natively support. You can use the official documentation for installation. And when it comes to Windows, Windows 10 is supported. But if you are using early versions, you have to use the Docker toolbox. It's actually a virtual machine that is running when it comes to the older versions of Windows. And Mac OS also, you can use the Docker engine directly. So using the Docker toolbox is a VirtualBox plus boot to Docker VM image. So this boot to Docker VM image is the where the Docker engine is running, and you will get a automatic GUI, a GUI-based tool to manage the containers, and you can use Docker CLI, Docker Machine, and Docker Compose. Docker Machine is used for clustering when it comes to Docker, and Docker Compose is used to write a set of containers that will be started with a single command. So you can write a Docker Compose file, which what are the containers you want to run and what are the interaction between them, like links. And using Docker Compose command, you can the containers. So when it comes to this boot to Docker, it's a really small VM image. It's about 30 megabyte, and it is running on most hypervisors, and it can also be run on actual hard drive. Okay, let's see how we can install Docker in a Linux machine. So here I have a Linux machine. So first of all, you can go to Docker official website, and from here you can select for servers, and you can select the OS version you have. It supports Ubuntu, RHEL, Oracle Linux, Fedora, Debian, CentOS, and Windows servers. So I will go to CentOS, and as you can see, there are two links for Community Edition and Enterprise Edition. So I will select Community Edition. And when you click this get CE from Docker store, so it will show all the instruction how you can install Docker on your machine. So this documentation describes how to install it on CentOS, or if you want to use it on another one, like Ubuntu, you can go to this link and click on this get C from Docker store, and it will show what are the steps that you have to run in order to install Docker. So today I have a CentOS server, and so I will try to show you how to install it. First of all, you have to use this. If it is not there, you have to install yum utilities. Then we are adding the repo for Docker. So if you go to, you can see there is a new repo added called Docker CE. Right, show the repository URLs. Then to install Docker, you just have to type this command. First of all, we will get a cache from yum. So now it is updated. Then using yum -y install docker dash ce. We are installed in the community edition. So this will take some time because there are like some dependencies that need to be installed. So as you can see, it is successfully installed. Then using systemctl, we can start this service. Systemctl start Docker. So if it is successfully started, you can type Docker, type enter. So you can see what are the commands that you have, like it has attach, build, commit, cp, create. So these are the available commands when it comes to this Docker CLI. So to test whether it is working fine, uh, we will run a small container. So type docker run hello world. Okay, since I have started it using root, I need to run root. As you can see, say unable to find image hello world latest locally. So first of all, when we type docker run, it will try to get check whether this image is on your local machine. So if it is there, it will run. Otherwise, it will pull that from the Docker Hub, and after that it will run. So using this hello world, you can check whether your Docker, the installation that you have done, whether it is working fine or not. So this hello world container, you can search about it using search for Docker Hub. So inside Docker Hub, you can search here. So if you type hello world, when you type it in here and search it, so you can see this is the official hello world image. You can go to details and see uh, what is happening with that Docker image, and in here you can see what is the command you have to run if you want to pull that image. So we will search for something like Ubuntu. So there is an official Ubuntu image. So I'm going to detail. So we have different versions. So if you type docker pull CentOS, so it will pull the latest version. So if you want to pull the version, for example 12.04, how to type docker pull CentOS, sorry, Ubuntu with the version number. So I will use the latest version. As you can see, it is pulling that image from the Docker Hub. To see what are the images that are in your local machine that the Docker is running on, type docker images. As you can see, there are like two images. One is the Ubuntu that we have uh, pulled now. It is 130 megabytes, and the Hello World one, and it is only 1.484 kilobytes. So we will see how we can run a Hello World one. So there is a container called BusyBox, and I will try to pull it. Docker run busy. Then you can give a command to run on it. So I will type echo hello Docker. So you can see it is downloaded and it has executed the command, and the hello world appears here. Okay, let's try to run some advanced content. So I have downloaded the Ubuntu container. So we'll try to start it. So the command is docker run. Then you can give the arguments you want. For this example, I'm giving it as -it and the image name. So in here, -I means it should connect us to the container standard input, and T means Docker. We need to have a pseudo terminal TTY. So when I started it, as you can see, I was on this server. Now I'm inside the container, so it has connected me inside the container. If I type something like apt, as you can see, apt command is working. The I installed Docker on CentOS 1, but now I have a running Ubuntu container, and we will try to install something in here. So first of all, I'm trying to get apt get update. So it will get the latest update from apt repositories. As you can see, it is completed. So I'm trying to install Figlet. So get install Figlet. You can see it is installed there. So check whether we can check whether the we have installed is working fine. So using Figlet command, as you can see, it is now working. So let's exit from this container, and to see the running containers, you can use docker space ps. As you can see, there is no running container since what we did was we ran a container using docker run -it, so it will connect the container, and when we type this exit, the container will be exited. To show what are the containers that are running and now also in exit status, you can use -a as the argument. As you can see, 2 minutes ago, 39 seconds ago, sorry, 39 seconds ago, this image, the container that we ran was exited. So let's see whether we run the same command and type Figlet. As you can see, it is not there since what we are doing inside the container in only will be there inside the container. When we run the Ubuntu container again, it will start it has started another container, and the changes that we have done is not there because containers are volatile. If you do something after running a container, do some modification, if it exists, all those changes will be lost. To overcome that, you can commit a container or save one. After that, the changes that you have done after running the container will be there. Okay, let's see how, since when we type this exit command, the container is exiting. Let's see, there is a way to overcome this, to run the container as a daemon. The command will be docker run, the same command, -it, and there is a new argument we have to give, -d, and we are giving the container, the image Ubuntu. As So you can see there is output given to me, that is the container ID. If I type docker yes, you can see there is one container that is up and running, 13 seconds. Okay, so then the problem is how you can connect to this container, because when we run it as a daemon, it is exiting from there. You don't it will not connect you inside default. So the command will be, there is two commands. There are two commands you can use. One is docker exec, other one is docker attach. So if you are using docker exec, type docker then exec space minus id, that are the arguments that you have to give. Then the container id, or you can use the name also, both will be working as same. And what are the command you have to run inside the container. For example, if I type something like ls, so it will execute that command and give us the output. For example, we want to connect inside the container, you can use something like bin bash. So as you can see, now I'm inside the container. And even if you exit from this container, the container will be running, since we have started it as a daemon. The other method to go inside the container, attach to container, is docker attach 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 container ID or the container name. So since I used the container ID in the previous example, I will use container name. As you can see, now I'm inside the container. To detach from it, you have to type you have to hold control PQ. Otherwise, if you type exit or something like that, the container will stop automatically. So assume you want to stop the container that is running. So the command is docker stop. And if you type docker ps again, as you can see, there is no container running. If you type docker ps minus a, you can see the container that we stopped, it is exited 14 seconds ago. You can also start a container that has been stopped. The command is docker start and the container ID or the container name. So I will give container ID and it has been started. You type docker ps. Now the container that we stopped has started. So things you have done to a container will be remain if you stop it and start it. But if you delete it and start it using the image, the things that you have done inside the container will be lost. Okay, let's see how we can commit the changes or build the container, Ubuntu container, which contain Figlet pre-installed. So there are two ways. One is using Docker commit, the other one is using Docker build. But the preferred method is using Docker build. Though I will show how you can use Docker commit. So the container that we ran earlier is there, still up and running. We'll try to connect inside that container. And I will get apt get update to update the repositories. Then apt get install Figlet to install Figlet utility. Now it is installed. You can check that using Figlet and giving some input to that. And I will exit this one. Since we ran it using daemon, it will be running there. And you can see the changes that you have done to a container using Docker commit and the container ID, the container name. Sorry, using Docker diff command. You can see the changes. As you can see, it will show what are the changes that you have done to the container that you started. So these are the files that has been changed. So you can see this file has been changed and this file has been added like that. It will show what are the changes that you have done to the image that you started. Then to commit this one, what you can do is Docker commit and the container ID. So it will create a new ID. If you type Docker images, as you can see with this ID, there is an image, you will create an image. And if the repository and the tag is none, since you just use the commit command. To give a name for that one, you can use Docker tag and the image ID. So you may see why here it has only 10 characters and this has more than that. So this is the shortest version of the image ID. You can use this the whole ID or the short one. It doesn't matter because both of them are unique. So I'm going to Docker tag the image ID. The name I am giving is Figlet. Then you type Docker images. So this one has now a name Figlet. So we'll try to run that one. Docker run -id and image name is Figlet. As you can see, since this image was there on the local machine, it was started without checking the Docker repository. To check whether the changes that you have done is there, you can use this Figlet command. As you can see, the Figlet is already installed in this image since we have done the installation on top of Ubuntu container and commit it. So the changes will be persistent. Okay, let's see how we can do this using Docker build. For that, I'm creating a new directory. file or Docker file. The name should be this. Then you have to write the script to generate the Docker image. So it will be something like this. So this means from Ubuntu, this shows what is the base image that you want to use, and using the run, you can execute command on top of this base image. So this is writing this script is same as using running a container and doing the changes manually and committing. Both are working fine. To check what are the syntaxes that are available for Docker file, you can search Docker file, and there's official documentation. So this Docker file reference will show you all the commands. So as you can see, these are the commands. So if you go to the from instruction, set the base image for the subsequent instruction. Like that, you can see what are the commands available. You can use run. Then if you want to copy a file from your local machine to the container, you can do something like copy, and using cmd, you can run some commands inside that. When the container is starting, you can give a command that will be started automatically when the container is running. So things like that. You can use this official reference document to see what are the syntaxes available to create the Docker files. So as you can see, I'm using the Ubuntu as the base image, and now I'm running two commands on top of that image: apt-get update and apt-get install figure. So I will save this file, and the command to build the Docker image is docker build. Then you can give a tag using -t. So I will give the name as fig, and you have to give dot. So it will search this directory for Docker file. When you find the Docker file, it will try to compile that one to image. So as you can see, now it has downloaded the Docker Ubuntu image. Then it is doing all the necessary commands that we have specified there, and successfully built. This is the ID of the image. So if you type Docker images, you can see the fig image is there. So let's check whether it is running fine. Docker run -it to connect to it, and the image I want is fig. You can use the image name or image ID, both will work fine. And check whether the figlet is working fine here. Type figlet. So you can see the figlet has been installed in there. So we can use this image. And when it comes to Docker images, I mean Docker files, remember always to run, when you run command by command, so it will create another layer. So it's working as a layers. So when you are building complex Docker images, always try to do chain commands. I mean, you can use a single command to execute multiple commands inside the container using run. You can change this one like something like this. So Using the single run command, you are doing the apt-get update and get apt-get install. So this will help to reduce the size of the Docker image that you are building. And another tip that you can use these. So here, this is a complex Docker file. As you can see, it is using CentOS version 7, and in here it has run a command inside that one. So this one needs to use MySQL, build the MySQL image. Then this one is the one I want to show you guys. You can define an argument and argument name and a value. So in here, I'm using argument MySQL version, and I have given a version my 5.5.52. So this variable you can use it in the Docker file. As you can see, to download the version, the correct version, I'm using this argument. So for that, you can use env also. Env will do the same thing, but using argument, you can pass a value to this MySQL version on the build time. So I will show you that. I'm creating another directory, build this image. So this is the Docker file I have. So the command to build it will be something like docker build. Then I will give a name as MySQL and minus build arg, and you can do something like this. So what it does is it will pass the value that you are given to this variable, and it will, inside the Docker file, that value will be used. So this is really helpful. For example, you want to build 3 images that have different version of the same software, something like Tomcat or MySQL. So you can use this technique using the build arg and this arg command to build that. So you can see now it is pulling the CentOS image. And it is downloading the version that we have specified, and it will be installed. So like that, this is really helpful when we are building different version of a same application to a Docker container. So this command has failed because there was a file that it needed that copy this docker environment.sh. Since I haven't copied that file to this location, that has failed. Okay, let's see. what we can do, like uh, basic commands. So docker ps will show the running containers, and ps minus a will show the running and all the stock containers. For example, you want to remove a stock container, the command will be docker rm, then the container id. So if you type again docker ps minus a, that hello world container is not there. But if you type docker images, that image, the hello world is there. To remove an image, you have to type docker rmi and the image name or image id. And if you type again docker images, as you can see that hello world docker image is not there since we have removed it. So let's see how we can view logs inside a container. For that, I'm running a small demo container. So it's called clock. So I'm pulling it and running it. If I type docker ps, now it is running that clock container. So to see a log, you can use docker logs, then the container id or the container name. So I'm using the container id. So you can see the logs inside the container. So this clock container will output the time to the standard output. So that's why the log contain some information related to the time. If you want to tail a log inside the container, you can use the same command with minus minus tail, minus minus tail, and give the value as 1. So it will show the last log line. So if you want to follow that one, you can use something like docker logs minus minus tail, and this is the number of lines you want to tail, and minus follow. So you can say minus minus follow. It should be minus minus follow. So you can see it will tail the logs and display the current logs on the container. So it is really hard sometimes to remember the how many containers using the image ID and this name. It is a random name generated from Docker, but you can specify a name when you are running a container. For example, when you are running a container like this, you can give a name using the argument. That is, the argument is minus minus name and the name you want. I will give this as here, okay. And if you type docker ps, so you can see the custom name that you gave to the container is there. So you can use this name to connect view logs and things like that without using the container ID. And to inspect about a container, so there's a command called docker inspect. So it will show the information about the container. So the command is docker inspect, and I will use the name. As you can see, it will show the information about the container, when it was created, and what are the arguments, and the running arguments, then the process IDs, and the log path, name, bindings, network, modes, volumes, things like that, CPU count, things like that. You can see uh, the information about the container. So this docker run command has many arguments. So so as you can see, docker run options. So you can give many options. To see what are the options you can give, you can use docker run reference guide. So there is a reference guide. The docker documentation is really good. It shows everything about the docker. It has every command and the description and everything is there. So there is a docker run reference. So as you can see, it show what are the parameters you can give, -d for d attach. Then you can give minus name to give a name to the content, like that. As you can see, the examples are given there, and you can do some advanced configuration like networking. You can specify what is the network that the container need to run on. Things like uh, that can be done using Docker run arguments. Then the restart policies, exit status, what need to be done after the container is stopped, like that, and runtime constraints. So you can limit the resources, like how much memory you are allocating to the container. Things like that can be done using the arguments, Docker run arguments. So there are details about all of these arguments inside in the Docker run reference. So let's see how we can uh, run something like Nginx inside the container. So first of all, we can check on the Docker Hub, is there Nginx image there. Always try to use Docker Hub, because and they are like always official repositories. So official means it is supported and it is tested. So always try to use, when it comes to Docker Hub, official repositories, because they are trusted by Docker. So there is Nginx official image. So the command is docker pull nginx. So first of all, I will pull that image using docker pull command. So now the Docker image is on our local machine, and we can run this using Docker run. Something like this: Docker run -id -d nginx. So if you type docker ps, it is running inside that container, the nginx. So I'm trying to connect to that container. Now inside that container. So let's check. Okay. Just type the ps, and as you can see, is running. Uh, so we will install curl to check whether the Nginx is working fine. So I'm installing curl inside the container, and we will try to curl localhost with the port 80. As you can see, the welcome to Nginx, that page is there. So using curl, but the thing is, if you go outside the container and type docker, just type curl local localhost on port 80. So it is not working. So since it's only isolated to the container that we are running, so to overcome this, we can use a port mapping. So I will show you how to do it. So using the same command, docker run. So first of all, I will stop this container. So now it's stopped. You can verify using docker ps command. Then what I'm going to do is docker run. I want to run this as daemon, and you can use port expose port using -p argument, and the command is so it will expose for example, I will give something like 8020. So what will this does is the port inside the container, the port 80 will be mapped to port 8000 of the host machine. So I will install in the Nginx. You can see it is running, and you can see the difference here. It is just saying this is running port 80 and 443. Here, as you can see, port 80 is mapped to local machine port 8000. You can verify it using local command. As you can see, the Nginx page is displayed from outside the container. So this is you have to use this -p argument a lot of time when using Docker, because that's how you can expose some port to the outside of a container. Okay, let's see how we can mount a volume. So there is a concept called volume in Docker. For example, assume you want to run a database in a container, but if it is stopped or you accidentally remove that container, data will be lost. To overcome that, there is a concept called volumes, where you can mount a host machine volume inside the container, and the container can use that volume. So even you remove the container or stop the container, the content inside that volume will be there. So it's a way to make persistence when you are using Docker containers. So what I'm going to do is so there is a Docker file here. So in the same location, I'm creating a file called test, and putting some inputs and saving that file. You can see that file is there here. So what I'm going to do is Docker, the command to mount a volume. First of all, let's check what is the directory that we are inside. So that's root mysql. So you can use docker run. The command to mount a volume is -v. That is also a docker run reference. So in the reference you can check that. So we will mount root mysql inside the host machine into /opt test inside the container. So I want to run this as a daemon, and I'm using Ubuntu. So the container is started. It seems like the container installed. So to check that, you can use docker logs. Why it has been stopped? Docker logs and the container ID. Seems like logs is there. So let's check using. Yeah. So I was missing that -it argument in my that container. So you can see now that Ubuntu container that I ran is up and running. So I am going inside the container using exec, and I will go into /opt inside the container. Okay, there is a folder called test there. But that as you can see, the files that are on the host machine are here. And what we can do is we will install vi with this file. I'm going to install Vim. Now it's installed. So we will change, do some modification to this file, and add in a new line and saving it. As you can see, now the container is changed. So let's exit from the container and check whether what happened to our file inside the host machine. As you can see, now it is updated. So the content, the things happening inside the container, we can have some persistence using Docker volumes. And let's see how we can do a linking between containers, like how we can communicate between containers. For this example, I will run a Redis container. So the command will be docker run. So I'm giving a name for that. Name will be Redis, and it should be run as a daemon. And there's a port mapping that should be happen. The Redis is running on should expose on 6379 port. 6 794 inside the container, and the image name is Redis. You can check this on Docker Hub. You can see it is pulling the Redis image, and it has started. Using Docker PS, we can see that Redis container is there. So the command that I'm going to execute is docker run. The minus d means run as daemon, and minus capital P. I have using the minus capital P. When we are using minus capital P, that means if you have configured the ports that need to be exposed inside the container, so that can be done. For example, using the Docker file, if you have something like expose and a port number, so it say this container should expose port 3306. So if you have something like that inside the container, or have multiple ports like that, so if you give minus capital P, it will expose all the ports that we have defined inside the Docker file. And to link the containers, I have used minus minus link. From minus minus link, I'm linking. This should be done using the container name. So I'm using the container name is Redis, and I'm linking it as Redis. So you can give the name if you want to this section. And I'm using some customized Docker image. So it's pulling that image in the Docker Hub. Now it is up and running. Go to Docker PS. You can see it is up and running. If you go to Docker.exec, I'm trying to connect to the container that I run, that is the application container. If you type something like ping Redis, as you can see, it is working. And you can use something like Telnet to check the connectivity. So first of all, I will update the repositories. Try to install Telnet. I'm using Telnet Redis, and the port that we gave to 6379. Let's check whether we can connect to inside that. As you can see, now I have connected to the Redis from the application container, and it is working fine. So this application container that I started, it is running from port 5000 inside, and it has automatically mapped to 32768 on the host, because we have used this minus p argument. this one. So let's check whether this is working fine, whether we can access this from outside. So I'm going to my browser and type the IP and the port. As you can see, now it is working fine. So this is using Redis to uh, store the number of requests, and as we refresh, you can see the number of request counts goes up. So I think that's about basic of Docker. And when in, so you can use this Docker official guide. It describes everything related to Docker, and it has examples also, so you can try that. And when it comes to Docker, when we are using this on production environment, we mostly use some kind of clustering mechanism. So we can use Docker Swarm or Kubernetes. Kubernetes is the most famous one, and we can use, and there is a huge ecosystem built top of Docker, so you can use those tools and plugins that has been on top of Docker. So then we can wind up for this session.
Okay,
Okay,
thank you very
thank
much.
you very much.
Thank you very much for being here to do this specific session, and I hope our guys enjoyed this session. And you can, of course, go through these slides and recorded video on our DevOps.lk YouTube channel. And again, thank you very much, Kasun, for presenting this great slideshow and help us to spread this awareness regarding uh, Docker and its usage. So let's meet up in another session with another new technology. Until then, we'll wish you all the best with learning Docker and related technologies. Thank you all.